Hello, thanks for joining me. In this episode, we're going to talk about determining the key features of rational functions algebraically. In the last video, I went over graphically. This one's going to be all about algebra. And I'm going to start off with this first example. The first thing that I like to do is check for holes when I'm looking at rational functions. And that's because you can't really find asymptotes without finding holes. And then also your domain, you need to know what the holes are. So it's good to just kind of get that out of the way. And so if I look at this function, holes are a little bit different than asymptotes. If you're looking at a vertical asymptote, that's when the denominator equals 0, but you have some number in the numerator. It's different for holes. For holes, you have 0 both on the top and the bottom. So that's just kind of a distinction you're going to want to remember. But so the way you kind of want to do this is factor anywhere that you can and see if factors cancel out. So I'm going to factor this. The numerator stays the way it is. I can't do anything. I can pull out an x in the denominator. So we have x times x plus 10. Okay, and I see that nothing cancels out. So if I had like a 6x plus 10 in the parentheses, if I had pulled out a 2, then I would have a 3x plus 5 on the top, a 3x plus 5 on the bottom. Those would cancel out, and I would have my hole at that x value. So that would be negative 5/3. But that's just hypothetical. We don't have that in this scenario. So no holes. The next thing is asymptotes. I just told you, if we're looking at the vertical ones, that's when you have an x value that creates a denominator of 0. And so if you want to find that, it makes sense that you would set the denominator equal to 0. And that's, of course, after you've removed any holes and you've simplified the function. But if I set it equal to 0, I can set my two factors equal to 0. And so I'm going to go ahead and erase this right here. One of them is going to be x equals 0. The other one is going to be x equals negative 10, if you were to kind of solve that out. And so we're done with that part. Horizontal asymptotes. There are kind of 3 different situations you have to remember with those, and I'm going to try to explain them logically, but if you would rather work with the mnemonic, I think you could probably find one online. But you'll probably remember from Math 3 that horizontal asymptotes deal with degree, and degree is just going to be the highest exponent. When we're talking about rational functions, though, we are comparing the degree on the top and the degree on the bottom. So we're kind of looking at this as a ratio of polynomials, 2 different functions that we're dividing and comparing. So on the top here, we have a degree of 1. That's my highest exponent. And remember, when I'm talking about exponents, I'm looking at variables and not just, numbers like 5 or 3. So degree on the top is 1. The degree on the bottom is going to be 2. That's my highest exponent that I have for my variable. We have a degree on the bottom that is greater than the degree on the top. And when that happens, you are going to have a horizontal asymptote of y equals 0. But now that we've talked about asymptotes, let's move on to domain and range. Domain is going to be affected by holes and vertical asymptotes. We don't have any holes, but we do have 2 different vertical asymptotes. So I'm just going to kind of exclude them from my domain. Negative infinity, negative 10, union, negative 10 to 0, union, 0 to infinity. So we have 2 different breaks there. The only thing that's going to interrupt our range horizontal asymptotes. So let me write that out. We have a horizontal asymptote of 0. So that's going to kind of affect my range. So negative infinity to 0, union 0 to infinity. Okay. The last thing is going to be, not the last thing, almost the last thing. We want to talk about intercepts. And so we have two different kinds, X and Y. And I'm going to start us off with Y intercepts. So if you think about it visually, that's when we have an X value of 0. And so it would make sense to plug in 0 for X to find our Y intercept. But you'll notice that when we do that, we get 5 over 0, which is not a real number. And that's because X equals 0 was one of our asymptotes. So Y-intercept, we do not have one. X-intercept is going to be when our Y value is equal to 0, so the other way around. And when you think about it, if you look back at the function, Y is going to equal 0 when we have a numerator of 0. Remember, if you have like 0 divided by 5, which is not 5 over 0, very important. 5 over 0 does not exist. 0 divided by 5 would be 0. So if you want to find the x-intercept, set the numerator equal to 0. And when we do that, I don't really have room for it here, but you would set it equal to 0 and you would end up getting negative 5/3. So our actual coordinate would be negative 5/3, 0. Okay, two more things. Positive and negative. That's when we're either above or below the x-axis. And so I am going to go ahead and show you how to do this. Your function is going to be positive where it's greater than 0. That kind of makes sense. Use a different color here. So we're looking where 3x plus 5 over x squared plus 10 is greater than 0. And I want to make sure that I write the bottom in a factored way. Okay, so where it's greater than 0. So the first thing that I would figure out is where it's equal to 0. And our function is equal to 0 at negative 5/3. So I'm going to kind of create a number line here. That's the way that I like to do this when we have an inequality. And so I'm going to put in my negative 5/3. We also want to add in, let me extend the page. We also want to add in our asymptotes that we found because those cannot be included in our interval. So negative 10 is 1, and then also 0. I wouldn't worry about horizontal asymptotes because that doesn't really have to do with domain. So we don't have to worry about that. But now we have kind of these different intervals that we want to look at. And so we might want to pick some test values that we can plug in so that we can figure out in these little intervals what the sign of our function is. So let me do that. I'll start from the right side over here. So if I plug in a number greater than 0, I can see that my whole function is going to be positive. So anything greater than 0 is going to be positive. Now we're looking at kind of a smaller range between negative 5/3 and 0. So let's pick a test point. So negative 1 is in this little interval here. And so I'm going to plug in negative 1. My numerator is positive, but my denominator is not going to be positive. It's going to be negative. So if I'm dividing a positive by a negative, I'm going to get a negative number. If you also want to write things on your paper like this for each section, that might help. I kind of like to do it in my head, but you also have to be careful because it's easy to mess up. So, all right, I'm finally ready to write my interval. I'm going to be negative from, all right, let me actually do a label here. Negative. I'm going to be negative from negative infinity to negative 10. So I'm going from left to right. And then skip that middle one, union, negative 5/3 to 0. Okay, and that's it. All right. Now we're going to do what's left with positive. So that's going to be from negative 10 to negative 5/3. Union, our next interval is from 0 to infinity. Oh, so that was a lot of algebra. But you really just have to practice it, and you'll have a chance to do that. Okay, last thing is end behavior. That is what happens to the function when x approaches infinity or x approaches negative infinity. So when x approaches infinity, we kind of want to think about our horizontal asymptote. That's kind of our end behavior, right? So it looks like our horizontal asymptote is y equals 0. So we can be pretty sure that y is going to approach 0. And so that's an important association to make, horizontal asymptotes and end behavior. And okay, so the next slide here, I have taken up quite a bit of time, but I want you to take a look at this and try it on your own and see how you do.